Hello boys and girls, this is Mr. Giomini. I have two problems for you today from the Unit 5 Pretest. We're going to start with number 6. This was one that was missed by probably 90% of the students, both from 1st, 3rd, and 5th period. So let's take a look first. Let me grab my pen. Alright, so point and say first. When Mrs. Spagnola swims straight across the middle of a circular lake, she swims about 100 meters. When she walks around the edge of the lake, she walks about 300 meters. Based on this information, write a statement that describes the relationship between the circumference and diameter of a circle. Okay, let me go back to this and kind of understand this a little bit better. When Miss Spagnola swims across the middle of a circular lake. Okay, so I'm going to draw a circle here, or something that looks like a circle. So there's my circle. Now it says when Miss Spagnola swims straight across, she swims about, so that's an estimate, about 100 meters. Okay. Now when she walks around the edge, now I know the edge of the lake, she walks about 300 meters. Now we don't call it the perimeter of the circle, we go around it, we call it the circumference. So when she walks around in this direction, she walks around the edge of the lake, we know that's about 300 meters. Okay, based on this information, write a statement. So I have to state something that describes the relationship between the circumference and diameter of a circle. Now all of a sudden they've changed this vocabulary. We've gone from the diameter, which I'm going to guess means that straight across. So this must be the diameter of the circle, and this must be the circumference of the circle. So they've actually changed the vocabulary here on me. So it's important that I know what circumference is and what diameter is. I know diameter is a line that stretches from one edge of the circle to the other, and it must pass through the center point of the circle. I know the circumference is the distance around the outside of the circle, or the perimeter. So I know there's some type of relationships. Let me see here. 300 is the one number, and 100 is the other. Well, I know that 300 minus 100 is 200, but that's not really a relationship. That I don't know if the circumference is always 200 greater than the diameter. Let's see here. How can I get from here to here? Because that's going to tell me more of a relationship. So adding 200, I don't know if that's going to be it. You know what? I think 300 divided by 3 will give me 100. Or 100 times 3 will give me 300. So I can either say that the circumference is 1/3 the diameter, or that the diameter is, or circumference is 3 times larger than the diameter, or I can say the diameter is 1/3 of the circumference. So writing my statement now, there's my keyword statement. Based on the data or information, I could say, provided I assume that the circumference of a circle is 3 times larger than the diameter of the circle. Now I'm going to take it one step further, and I don't know how many of you know this. Circumference of a circle is really equal to pi, which I know all of you know that, times diameter. Now we know that pi is equal to 3 and 1400ths, which a bunch of other numbers, but we're not really concerned about that. Now I know that, look at that, I take 3, it says 3 times d, so this is where I get that 3 times about. The keyword here being about. That's where I get that about, because if the diameter is 1, the circumference would be 3 14/100ths. So I know that, because again, pi goes on forever, that's why we say it's an about. I know that now the circumference, because that's what we'd use here to solve this, that the circumference is always going to be about 3 times larger than the diameter. Okay, that should help me with that problem. And again, that's a 2-point problem, so I put some time and effort into that. I look at question number 6 now, and I believe this is, or I'm sorry, this is question 6, I believe, with Mr. Hartwell, or this is question 7, I'm sorry, with Mr. Hartwell, and he's retiling his bathroom floor. So take a look. Mr. Hartwell is remodeling his house. He wants to put 1-foot square tiles on the bathroom floor. So that means each side, I'm trying to visualize that, if I have a tile that looks like this, each side of that tile would be 1 foot, because it's 1 square foot. He decides to change the size of the bathroom from 5 feet by 8 feet to 10 feet by 8 feet. How many more tiles will he need for this new and improved larger bathroom? This reminds me of the Miss Banjoff problem with her garden. So let me take a look here. Originally, Mr. Hartwell's bathroom was 5 feet by 8 feet. And if I'm putting tiles down, and I'll just draw a rectangle here to kind of visualize the size of Mr. Hartwell's old bathroom. So it's 5 feet by 8 feet. Okay, and I want to put tiles on the inside. So that means there'd be 5 tiles going across and 8 tiles going down. Okay, now I need to find out how many tiles would cover the whole floor. So I'm finding area. 5 times 8 equals 40. So originally Mr. Hartwell would need 40 tiles to tile that old bathroom floor. But it says here how many more will he need for his new and improved. So now we're going with the new improved, the 10 foot by 8 foot. Mr. Hartwell is going big time now. So now I'm just going to kind of go over here. Let's see here. Make a bigger square. Now he still has the 8 feet, but now he has 10 feet. So now I know I have 10 tiles going across. 3, 4, 5, 6, 7, 8, 9, 10, and 8 going down. 1, 2, 3, 4, 5, 6, 7, 8. The reason why I'm drawing pictures is because I noticed when I was going through the pretest, very few of you drew any kind of illustration to help you solve this problem. Sometimes drawing pictures will help. So now I know that Mr. Hartwell is going to have 10 going across, 8 going down. I know many of you know how to multiply this array. It just becomes 10 times 8, which equals 80. So his new bathroom will have 80 tiles. It says here, how many more will he need for his new and improved? Well, if he originally needed 40, the new one needs 80. So I just take 80 minus 40. He needs 40 more tiles. So obviously A is not correct. B, 8 tiles, no. C, 40 tiles, D, 80 tiles. Well, they're trying to trick me here because I did get an answer of 80, but that's how many tiles he needs for the new bathroom, not how many more he needs. So how many more he needs is 40. Okay, remember, for this problem here, make an illustration. Pictures will help. Have a great day.